Good afternoon, ladies and gentlemen. This week we're going to be talking about multi-digit multiplication, which is really just a three-digit number or more multiplied by a two-digit number or more. This year in fifth grade, students are only expected to master up to three-digit by two digits, so that will be our primary focus. Um, Most of us in school long ago were taught what was known as the standard algorithm. Algorithm just meaning a series of steps or instructions. And we were taught that all you had to do was take the first number, multiply it by the three numbers on top, which in this case, let's see, would give us 2 times 9 is 18. Whenever we were given a multi-digit number, we were taught that the number on the right, or in the ones place, went down, and the number on the left or in the tens place went up. So the one's going to go up to the number next to it. 2 times 2 is 4, plus 1 is 5, and 2 times 3 is 6. The second part of this standard algorithm, as it's called, would be to take the tens place. And we were taught in school, well, just make sure that on the second row, when you start doing the second number, you always start with a 0. Maybe we had a good teacher, maybe we did not, but most of us never really understood the reason for that 0. We just knew it had to be there in order to accomplish this successfully. Anyway, so we go on with our 4. We do 4 times 9, which is 36. Put a 6 down here, 3 up top. We're done with that 1 from before. Then we do a 4 times 2, which is 8 plus 3, which would make, let's see, 11, right? And 4 times 3, which is 12, plus 1 is 13. Then we were told after we did all that work and we had both of those sets of numbers, regardless of whether or not we understood where they come from, as long as we had those numbers, we just had to add those together. And let's see, that would give us 8 plus 0. There's 8. All right, so we had our answer. Did we understand how we got there? Maybe not, but we knew we had the right answer and that was what was important. Unfortunately, or fortunately, depending on how you look at it, kids and students these days are held to a much higher expectation. Um, it is the thought that by helping students to understand the algebraic reasoning behind the numbers and being able to manipulate and decompose the numbers will help them later on in life, whether they choose a mathematical um, job or loss of words here. Um, anyway, whether they choose something that involves a heavy use of math or not. The ability to think algebraically is simply the ability to think in patterns, to break up large problems into smaller, easier to work problems to work to a good solution and a solid solution. So, to that end, this year we're going to teach kids, along with the standard algorithm, it is expected by the end of fifth grade that all students be able to use the standard algorithm. However, that is at the end of fifth grade. There are several baby steps we need to take along the way, some more than others. Some will be able to skip steps, some will not. It depends on how their individual brains work. So let's start with that same problem again, 329 times 42. And the first thing I'm going to review with the students, and we started last week with our homework, is the decomposition of numbers, or breaking up numbers into addition problems that would still equal what we're given. Many of you know this as expanded notation. Students learned it as early as second or third grade. But really what we're going to do is I'm going to break up each of these numbers, 329 and 42, by their place values, that being the ones, the tens, and the hundreds. So 329 broken up by its place value, 3 in the hundreds place means we have 300. 2 in the tens place means we have 20, and 9 in the ones place means we have 9. If we were to add those together, we would get 329. Same way with 42, that would give us 40 in the tens place, 2 in the ones place. So mathematically, and most of us weren't taught this until middle school or high school, but I do work with the kids now as early as fifth grade in understanding this. Some students are able to understand it as early as third grade. But Really, all we're trying to do in multiplication is multiply the groups of 329 by the groups of 42. As long as we multiply that entire group by the other, we're going to get to the answer. But there's nothing that ever said we had to multiply the groups all together at once. We can easily break them apart, again, as long as we multiply them by each other. I'm going to stretch this out a little bit just to give you a better idea as to what I'm talking about. Let's see, 40 plus 2 times, because we're multiplying these two numbers by each other, 40 plus 2 times 300 plus 20 plus 9. So, may look a little bit familiar, maybe looking into high school. You had problems such as x plus y times x squared plus x plus 2. Again, very similar, but we're working with the numbers already. And it's actually very simple for your students to understand. And again, they'll have more reinforcement of this in 6th grade, but they're going to use what's known as the distribution property. They're going to distribute or pass out every number here in our first set of grouping symbols. We're going to pass that out to everything in our second set of grouping symbols. So our first number was 40, and I want to multiply that by 300, so that would give me 40 times 300. I'm also going to multiply that by 20, so that would give me 40 times 20. And last but not least, I'm going to multiply that 40 by 9. That gives me the 3 different problems. We'll get to that in just a moment, but I want to multiply that second digit in the first set of grouping symbols. The 2, I'm going to multiply by the 300, which gives me 2 times 300. 2 times 20. And 2 times 9. So, 6 total problems. The first 3, 40 times 300, 40 times 20, and 40 times 9. Those first 3, if I multiply those, and we talk about this property in class of our zeros being those tens place, those placeholders, and in multiplication, if we're multiplying, we have those zeros at the end, we can just move those over. If you want to know more about this or know why, please make sure you and your student reach out to me. We can talk about it in Class Dojo. We can have a parent conference if you need more details to be able to help them out at home. Now, by taking those 3 zeros, all we have left is the 4 and the 3. Well, 4 times 3 is something we learned in 3rd grade. That's 12. So now we know that 40 times 300 equals 12,000. Same thing with the zeros here, 2 zeros. I'm left with 4 times 2, a very simple 2-digit problem. 4 times 2 is 8, gives us 800. Last but not least, we bring that 0 over. We're left with 4 times 9. One of our math facts from 3rd grade, 4 times 9 is 36. And I now have 3 what are known as partial products, meaning they are part of the final product, because when we multiply 2 factors in math, a little bit of vocabulary here for you, factor times a factor gives us a product. All of these, factor, product, and partial product, are all essential vocabulary for your students to learn and understand this year, because they are vocabulary that's going to be used on their STAR test and on their their 6-week tests as we move throughout the year. Again, it may seem a lot at first, but helping our students to understand these things very early on will help them to think more algebraically when they get to the higher grades. It'll also help them in other subjects with problem solving, again, by breaking up a large problem into a smaller problem. Let's go ahead and finish this one up, because we still don't have our final product. We don't know if we're still going to get this 13,818 that we had gotten before. If we add up these first 3 partial products, I've got 0, 0, That's going to be 11, 3, and 1. I'm up to 13,100. I'm close to 13,818, but I'm not quite there. That's because I haven't added up the partial products of this 2. So far, all I have found is 40 times the 329. Oh, wait, I made a mistake. Let me back up. This actually was 360. That was a 6. I'm glad I caught myself here. Which means this should be 13,160. And this is important because if you notice, this partial product of all these red numbers, this 40 times 329, is the same as the partial product that we got before, 13,160. That's something a lot of us didn't understand earlier. When we're using the standard algorithm, this is the partial product of the tens place times everything up top. We're looking at 329 times 40. At the same time, what we're about to see is that these top numbers, when we multiplied that 2, was us doing 329 times 2 and adding those two partial products up together to get the final product. So let's see if we can get that 13,818. We've gotten 13,160. We just need to see if we can get that 658. We should have that in down here where we multiplied by 2. 2 times 300. 2 times 20. And 2 times 9 gives us 640 and 18. Should have lined those up to the right so my place values are lined up, but 0 plus 0 plus 8 is going to give me 8. 0 plus 4 plus 1 is going to give me 5, and then that 6 comes down to give me 658. Just like before, 658. So, if students aren't able to understand the standard algorithm, this distribution model, as some like to call it, is just as effective. As you can see. It allows the students to break it up into smaller parts. But just like before, you can see there's a lot of work going on at the same time, and this can still be confusing for some students. Luckily, I have yet another strategy for students to use, and I believe this one is their favorite. Coming from 4th grade, they already know how to use it for the most part. We're just going to add to it a little bit. They know it as the boxes method. Here we go, 329 times 42. I'm going to refer to it as the area model, simply because we are going to make these boxes, as the kids call them, or windows, bigger and smaller based on the place values that are going to be multiplied. So again, we're going to use the same numbers as before, 329 times 42. Those magic numbers that we got before for our partial products, we'll bring this back later, are 658 and 13,160. But I'm going to break these numbers apart by place value, 329 and 42, just like I did before. 300 plus 20 plus 9. But this time, instead of doing the 42 horizontally like I did these ones, I'm going to do the 42 vertically. You can do this on either side, left or right. 40 plus 2. I teach the students to draw a line underneath all the numbers on top and draw a line to the right of the numbers on the left. Opposite if you did the numbers on the right, of course. But we don't really have a box yet. We don't have something we can do that we can multiply, which is what we would use the area formula for, length times width. Let me put that up here. That might be helpful, right? Area model, also known as boxes by the kids, or windows. They all like their names. Anyway, back to our area model. We don't really have an area or boxes or windows, whatever you want to call it. So we're going to go ahead and box that in. But now to make sure we have those place values, the hundreds place, the tens place, the ones place, and for us to be able to tell where we should have our small partial products, our large partial products, is right now, these are our factors. We're multiplying 320 and 9 by 40 and 2, but we have to do that with each one. Here we go. We're going to use our plus signs to make our window panes for our area model. There's a plus sign. And right away you can tell I have some boxes bigger than others. Well, when we're multiplying, depending on what we're multiplying, we have products that are bigger than others, so we should. And again, our little trick with the zeros, because of our placeholders, place value, those zeros come in handy. You'll see what I mean here. Our first box, area model, remember, area model, here's why it works. Area, the formula, is length times the width. Let's see, let's do some different colors for this, shall we? We'll do length in this pretty green, right? And let's do our width in tiger orange. Why not? Length and width. So the length of this first box right here in the upper left-hand corner would be 300. Does it really matter whether or not this is the length or this is the length? No, as long as you decide and are consistent with which one's the length and which one's the width. Don't change halfway through that you're using this side for the width and this side for the length, and then you're going to change it to the length and width. Just don't change it. Decide what you want to do and stick with it. I'm going to make the top portion the length, and I'm going to make the side portion the width. The length of this box is 300. We're multiplying, this is area, right? Yeah, we're multiplying 300 by the width of this box, which is 40. So 300 times 40, excuse me. This second box, the length is 20. The width is 40. On this last one, our length is 9. Our width is 40. Yes, all those numbers should be the same here on the top. If you're seeing that pattern, you're doing a great job. 9 and 40. Let's not forget our multiplication. This is the area model. It's length times the width. On the bottom, a length of 300. Notice the pattern. On this one, a length of 20. Notice the pattern. At the bottom, though, the width on this one, the width has changed. It's that 2. 2. The width here, if I follow it over, it's the same. It's still 2. While I'm filling this in, I hope you can already guess what the two numbers are going to be in our final box. The length, I gotta look up. The width, I gotta look to the right. You should have seen 9 times 2. Now, let's go ahead and start multiplying these out so we can get our two different partial products. They will appear here on this side. Because we are going to see these plus signs, we're going to bring those down and add up what we get in each of these boxes, and that will give us two different partial products. Here we go. First one, I'm going to use my strategy with the zeros, knowing my placeholders can come down first. There are 1, 2, 3 zeros, so I'm going to write 1, 2, 3 zeros. Cross those out as I use them, and I'm left with 3 times 4. 3 times 4, easy third grade fact. 3 times 4 is 12. I call these easy third grade facts, but please keep in mind, not all students think the same and are developing the same. So if your student hasn't gotten their math facts up to 12 memorized already, please be working with them at home on a daily basis. Make it a part of homework or make it a part of your car ride home. If you need flashcards, talk to me. We can get some for you. We'll get them checked out. It's not a problem. But students are not going to improve unless they're practicing the things that they need to practice for themselves. Here we go. The next one, I have 2 zeros. 1, 2, cross those out. 2 times 4 is 8. The last one, I have only 1 0. Still gives me 9 times 4, which is 36. Here I have my 12,000 plus my 800 plus 360. 12,000, 800, 360, 06, 13,160. Sound familiar? Let's do these bottom numbers. I've got 2 zeros. 3 times 2 is 6. 1 0. 2 times 2 is 4. And 9 times 2 is 18. That gives me 640 and 18. 8, 5, 658. Do those numbers sound familiar? 13,160 and 658. That's right. They're the same partial products we got before. Does it look different? Definitely. Might getting those zeros out of the way and breaking up these big problems into smaller, easier to read sections be easier for your student? More than likely, but I'll let you and them be the judge of that. I'll leave you with one last strategy, as the students will call them, a way of doing things. It's still using decomposition. But I'm going to only decompose one number because most students don't need the help of breaking up the entire problem, such as in the area model or our full decomposition model. So starting with the same numbers again, 329 times 42. And this time I'm going to break up only the 42, which would give me 329 times, we put grouping symbols, again, this helps that algebraic thinking, but it's also going to help when I go over order of operations. Yes, we learned that in 5th grade now. Look forward to a nice little song and dance later in the year, but they do need to know order of operations in 5th grade, so this is going to help that as well. 40 and 2, if we break that up by the place value, 40 and 2, here we go, the tens place and the ones place. That would give me 40 plus 2. And as we discussed earlier, we can use the distribution property where we just pass these numbers out and make sure that they're multiplied by all the numbers. Well, in this case, we have just 1 on this side, which is 329. So as long as I multiply that by 40 and by 2, I'll get the 2 partial products that I need that will give me this full product for 329 times 42. So in this case, that's going to be 329 times 40 and 329 times 2. To help the kids set this up, I encourage them to write down their first number, which in this case will normally be the larger value number, and write it down however many number of times they have a digit in the second number. So in this case, I have 2 digits, so I'm going to write 329 2 times because I have 2 place values. Then I'm going to take the place value of the first, in this case the 40, 329 times 40. But when I have them write it down, we are going to scoot it over to the right and let that 0 hang off so it doesn't stress out the students too much. When we provide too much information or too many things to look at, it can be a bit overwhelming. Luckily, with this place value of 0, since we decomposed 42, I can just drop that down and not have to worry about it. Now I'm back to a third grade level problem, which for many of our students eases a lot of that anxiety and makes this much easier to handle. 4 times 9, 36. 4 times 2 is 8, plus 3 is 11. 4 times 3 is 12, plus 1 is 13. Oh, these numbers are looking familiar again. What was our second one? After our 329 times 40, it was 329 times 2. Look at that again, a nice, easy third grade level problem because we have just one digit. In this case, it's even 2. It's one of our favorites in 5th grade. 2 times 9 is 18. I bet you can't guess what number I'm about to get. 2 times 2 is 4, plus 1 is 5. And 2 times 3 is 6. Again, both of these numbers are only partial products. I still have to add them together in order to get my final product. So, I know it was a lot. I hope you'll take time to go back and revisit this video, especially the portions that you and your student find helpful, and find the strategy that works for y'all. Find the strategy that works for your student, most importantly. We will be going over all of these in class this week, as well as giving the students plenty of opportunity to practice the strategy that works for them. Should you have any comments, don't forget, leave a comment below or hit me up on Class Dojo. We can only get through this together and help our students be the best that they can be together.